Hey guys, welcome back to the channel Techbeast.org. So today what we are going to see is the part 2 of our Kafka tutorial. Okay, so in part 2 we are going to set up our own Kafka cluster. Okay, we are going to produce our own simulated sensor messages. Okay, and we are going to send it to our Kafka broker and consume it. Okay, so in case if you have missed my part 1 video, I strongly recommend please do watch it, guys. Okay, so I have explained clearly about what is Kafka. Okay, so what are its use cases really in industries today, and some of the technical components which is making Kafka possible and an excellent tool for real-time event streaming. Okay, so let's get into the architecture and the setup today. So this is our setup. So we are going to have two Kafka brokers and two zookeepers. Okay, 01 and 02, as you can see in my screen. So we are going to run these brokers and zookeepers as a Docker container. Okay, so that's why you are seeing here two ports. Okay, so 9092 and 9093 for the respective brokers, and 29092 and 29093 for the um, internal Docker communication. Okay, so if you want to reach out to host, we will be using reach out to broker from the host, we'll be using 9092, and if you want to communicate with the broker within the containers, we will be using the 29092 and 29093 ports. And for Zookeeper, it's 2181 and 2182. Okay, so similar way. So this is our setup. It's a simple setup. So with the two brokers and two zookeepers. Okay, so you can easily understand how brokers are able to collect all the real-time messages from the producers, and how consumers are consuming it. Okay, and in the way that both are decoupled. Okay, so let's get into the session. But there are some prerequisites you need to note, guys. Okay, so make sure your laptop or server have Docker and Docker Compose installed. Okay, so then I assume Python is there, and make sure Kafka Python module is installed, because we are going to uh, execute some Python based Kafka API, okay, to produce and consume some messages. And some of the sample codes to help you guys, I have uploaded in GitHub, and this is the repository URL. Okay, so you can note this down and you can refer it. I have given this in the description as well. Okay, so you need to create a data folder. Okay, so this mainly to mount your local folder with the container. Okay, so that you can able to get all the configurations of the brokers and the zookeepers. Okay, so this is the GitHub page. Okay, so I'll just quickly show you what are the files and folders located inside. So this GitHub folder has all the commands which you need to play with Kafka. Okay, so basically I'll just go through one by one in this tutorial, but just want to share some information before we do a hands-on. Okay, so then this is our Docker Compose YAML file. So this will really make your life easy to set up a Kafka cluster in your machine. Okay, so we will be having two zookeepers, as I mentioned, and two brokers. Okay, so there will be two ports. We are going to map it. So 9092 and 9093. Okay, for broker 02. So both for external and internal communications, and some of the environment variables we are going to set. If in case you want to learn more, you can always refer Kafka documentation. Okay, to understand more about the functionalities of each environment variables. Then of course, as I said, we need to create a data folder. Inside the data for Kafka 01, we are going to map all the configuration files from the container to this particular folder. Similarly, for broker 02 and zookeeper 1 and 2. Okay, so this is just a glimpse of the Docker YAML compose YAML file. Okay, then we will have a producer Python program and a Kafka IoT consumer Python program. Okay, so we are going to use this Python API to interact with the Kafka cluster. Okay, so let's get into the session. So here I have already cloned my Git repository. Okay, so just by running git clone and put the URL, you can able to clone it. So once you clone, you will see all these files presented inside. Okay, so let me open it in a code editor. So just by typing code space dot, I'm going to open all these files and folders in a Visual Studio Code editor. Okay, so this will make my life a bit easy. So, okay, let's straight away go to the Docker Compose YAML file. Okay, so here we have the Docker Compose YAML file, and all you need to do is open the terminal. Okay, so just run the command docker compose up dash D. Okay, we are going to run everything in backend. So in my case, it's already running. So if it's not running, it will just show done, 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 done. Okay, so once your configuration, everything is properly mentioned in the compose. Okay, so this will start these 4 containers, which you can see by executing the command docker ps. Okay, so you can see my broker, 2 brokers are running, and at the same time my 2 zookeepers are already running. Okay, so now how I'm going to interact. Okay, so we are more interested into it, right? How each components are working, how Kafka is storing the messages. Okay, I'll show you one by one. Okay, so you can go to the command, you can go to the list of commands here, which I have given it under Kafka commands. Okay, so basically this is the command we are going to use to log into the container, docker execute. Okay, so dash it is the interactive terminal for the broker 01. Okay, so let's log into the broker 01. So this will straight away log into my container. Okay, and inside the folder cd/opt Bitnami Kafka. Okay, because we are using Bitnami's Kafka image here, which you can see in the Docker Compose file. Okay, so you can see here it's the Bitnami's image. Okay, so there are many providers like Confluent, and there are so many. But for this particular tutorial, we are going to use Bitnami's Docker images. Okay, so inside this Kafka and inside the bin folder, you will see all the supporting um, commands. Okay, so to create the topic. Okay, so to Kafka console producer, console consumer, Kafka consumer group. Okay, Kafka topics. Okay, it has everything. Okay, all the functionalities of the Kafka using this sh bash script, we can able to interact. Okay, so the first step is I want to publish some messages. Okay, so I want to produce and publish some messages. So basically we need to have a topic. Okay, so in Kafka, as we already mentioned, every message will be produced and published to a topics, and consumer will consume the topic. So the next step is to create a topic here. Okay, so to create a topic, so this is the command. So you can always specify the number of partitions you want and the number of replication factor. Okay, so in my case, let's keep the partition as 1. Okay, so and we can create the topic of IoT telemetry temperature. Okay, so just assume it's a temperature sensor we are going to publish here, and that's why the topic name is IoT telemetry temperature. And I'm going to give my brokers the UR, the address, the port, and the host of my broker. Okay, so in my case, broker 01 is the Kafka broker, and 2902 is the port number which I'm going to access internally. Okay, so that's why I'm using 2902 here. Okay, because we are executing all these commands inside the container. Okay, so that's why I'm using such internal ports. Okay, so let me straight away just copy paste this and just enter it. So just wait for a while. It will create a topic called IoT telemetry temperature. So you can see here, created topic IoT.telemetry.temperature. Okay, so successfully the topic has been created. Okay, so now if you want to list down the topics, list of available topics, you can use this Kafka command, Kafka topics. You can specify the bootstrap server, which is your broker's host and port number, and just list it down. Okay, so this will straight away list down the available topics in the Kafka cluster. Okay, so here you can see when we listed, we have only created a temperature topic, so that's why it's showing here. So if you want, you can create more topics based on your use case, and you can just take a look at it. Okay, so then okay, let's copy this to get the details about the topic. So I have copied it, then let's paste it here. So we are going to describe the topics details. Okay, so it has just other than the name, it will show more informations. Okay. Okay, so these are all the details as you see here. Okay, so what is the replication factor? Okay, what are the configs? Okay, so what's the partition counts by default? Okay, okay, so in our case, partition we have given 0. Okay, so these are all the default partition it's given. So all these consumer offsets are created by Kafka. It's not something which we create. Okay, so what we have created is, you can see here, IoT telemetry temperature. Okay, so this is the topic ID, partition count. Okay, we have given only one, replication factor as 1. Okay, and this is the partition ID. Okay, so ID is starts from 0 to n. Okay, and leader 2. Okay, our leader, our Kafka, our broker 02 is the leader assigned to this topic, and you can see the number of replicas and other details. Okay, so in this way you can able to see and deep dive a little bit more about the topics. Okay, so we can just to show you guys in simple way how you can use a CLI to directly publish some messages. Okay, so here you can just put this copy this command Kafka console producer and the bootstrap server and the topic. Okay, so we can straight away publish it. So I've just let me open another terminal parallelly. Okay, and I will log into the Docker the Docker, the broker again. Okay, so Docker execute -it broker01 /bin /bash. Okay, cd opt bitnami kafka bin. So here we can able to consume the whatever the messages we are able to produce. Okay, so here I'm going to consume everything from the beginning, so that's why I have added this option from beginning. Okay, so let's just consume the messages. So here I'm just gonna type something, for example, okay, test message is just to show you guys. Okay, so once we produce this message, you can see the consumer already consumed it, test message. Okay, so this is test message 02, and you can see the consumer is consuming the messages, okay, in real time. Okay, so it's cool, right? So let's do a little bit more other than just publishing and testing with some random strings. Okay, so these are just delete commands, which I'm not going to show you guys. In case if you want, you can able to try it out. Okay, so it's more like managing the topics. Okay, so along with this, as I mentioned, we can also able to create a topic with multiple partitions. Okay, so here we have used the partition 1, and here let's say we are going to use 3 partitions. Okay, so this will be helpful when you create multiple consumer groups. Okay, so each consumer group, the messages will be randomly stored in partitions. Okay, and the consumer, all the consumer groups will get all the messages. Okay, which will be stored in the multiple partitions. Okay, so we have already mentioned messages are not stored sequentially in the partitions. Okay, so it will be randomly shuffled. For example, partition 1 will have message 1 and 2, and partition 2 will have message 4 and 5, and partition 3 will have message 3 and 6. Okay, so these are all the things Kafka manage by itself and assign the messages to the partitions. Okay, so let's create a topic with multiple partition here. Okay, so let's copy this command. Okay, so you are going to create a topic okay, IoT telemetry temperature with 3 partitions. So let's open it. Then I'm going to cancel my publish, and I'm going to cancel my consuming. Okay, so you can see here processed a total of 2 messages, because 2 messages are produced and 2 messages are read, and that's why you are seeing this notification. So let's just create a 3 partitions. Just copy this and paste it here. Okay, so let's wait for a while. It will take some time. So the 3 partitions for the same topic name, IoT telemetry temperature, will be created. Oh, okay. Okay, sorry, the warning, I think you can ignore it, but the problem here is we already have the IoT telemetry temperature. Okay, so that's why we cannot able to recreate the same topic name. Okay, so we can able to, let's just change, for example, humidity or whatever. Okay, so humidity. So this is just to show you guys how you can able to create topics with multiple partitions. So create a topic, IoT telemetry, humidity. Okay, so these are all the information here. Now, if you describe more here, this will have all the details. Okay, so let's exit it for a better view. Okay, so you can see here our telemetry temperature have 1 partition, and our humidity humidity topic have 3 partitions. Okay, so you can see here partition 0, partition 1, partition 2. These are all the partition IDs. Okay, so it's pretty cool, right? So these are this is how you manage the topic, and you can produce and consume messages in Kafka. Okay, so now let's see how Kafka stores these messages. Okay, so before we understand how the Python API works, let's just understand this a bit. Okay, so just run the command ps-ef grep Kafka. Okay, so this will show the entire the ps-ef is I'm just executing and checking the process, Kafka running process, and when you run this command, you will see where the Kafka server properties are located. You see here Kafka opt bitnami Kafka config server dot properties. Okay, so let's just copy this, and I'm gonna open it, okay, to show you guys what are the properties being set. Okay, so let's just copy and paste this. I think didn't copy properly. Let's copy it again, then let's just paste it. Okay, so these are all the properties, guys. So you can see here all the Kafka configurations and properties are mentioned here. Okay, so here we need to look for the directory where the log files and data are stored. So you can see here under the log basic section, the log directory is located in bitnami Kafka data. Okay, so this is where the messages are stored. Okay, so there are other configurations which you can take a look as well if you want to know more. So now let's straight away go to this folder to see the Kafka data. So let me delete the log dash and straight away go to this data folder. So inside this data folder, let me list and see. You can see there are, just ignore all the consumer offsets because these are all managed by Kafka. Okay, so let's just focus on our created topics. Okay, so IoT telemetry, humidity 0, IoT telemetry, humidity 2. Okay, so you can see there are other uh, the topics we have created. You can see each and every folder is located here. Okay, so now what we need to do is let's just go to any one of the folder, IoT telemetry humidity 0. So inside the folder you can see triple 00 dot log. So basically this is where this file is where the Kafka will store all its data and messages. Okay, so currently we did not produce any messages for this topic, so that's why the size is 0. Okay, so here we see that humidity 0 and humidity 2, 0 and 2 partition. So you'll be wondering where is the temperature we created and where is the humidity 1 partition is located. Okay, so as we saw in the in our execution, so you can see here the leader is 2 here. Okay, for example, partition 0 is in broker 1, so partition 2 is in broker 1. Okay, so that's why we are seeing only this 2 here. If you log into your broker 2, okay, inside your container, and if you execute the same, you will see the partition 1 and our IoT telemetry temperature, okay, which is which both are assigned under broker 02. Okay, so this is how the Kafka manages the higher availability and of your messages. Okay, so here now what we are going to see is we are going to produce some messages, okay, using Kafka IoT produce a Python program. Okay, so here we can see here I have just defined some temperature simulator here. So you can basically use this function to integrate your own sensor data or some real-time sensor data or sensor from integrating with Raspberry Pi or whatever. Okay, so you can just integrate within this function and you can return the value. Okay, so here I'm just using a temperature simulator which will simulate a temperature within the range of 25 to 35. Okay, so then I'm going to use this function and publish to broker. Okay, so here what we are going to do is something bit more. Okay, so here I have used keys. Okay, so we are going to segregate each messages by its keys. Okay, so here I have created hall, kitchen, bedroom, and study room. Okay, for example, temperature of hall, temperature of kitchen, bedroom, and study room. Okay, and I'm going to publish it, and I'm going to produce the data here under this topic. Okay, so every 5 seconds we are going to send this. Okay, so let me just run this script. Okay, so this will straight away start the Python program, as you can see, connected to broker, sending data to Kafka broker. Okay, so let's start to read this message. So we can go to the command here. Okay, so consume messages, okay, using consumer group. So here what we are going to do is, so we are going to consume the message using a consumer group functionality. Okay, so I'm going to use a test consumer group here. Okay, so you can give any name. So in this case, it's just a test consumer group, and we are going to print the key here. Okay, so we want to know under what key the data is being tagged, and we are going to separate the key separator by equal to command. Okay, let's just copy this and let me just execute it here. Okay, sorry, I'm not inside the Kafka directory. So let's go to op bitnami Kafka bin. Okay, so now I can paste this code. Okay, so now as you see here, my Kafka broker, we are producing it for all the 4 keys. Okay, and it's being published to IoT telemetry temperature topic. So here we are reading the consumer group from the beginning. Okay, so see, initially we did not give any key. That's why we have published 2 messages, but we did not give any key. So that's why the key value here is null. But in our Python program, we have clearly specified what key we want the data to be stored. Okay, and you can see clearly hall, kitchen, what is the temperature, bedroom, what is the temperature, study room. Okay, so similarly, Kafka will store all these informations. Okay, so there is one thing. So messages from the same key will always end up in same partition. Okay, so if you log into the partition, and as I shown, and you can check the data, messages from the same key will always end up in the same partition. So now we have used the CLI to consume the messages. Okay, so we have a Python program here as well, which will do the same thing. Okay, so you can see the Python code here. We have a consumer. We have specified the bootstrap server, which is our Kafka broker. So since we are accessing it via the host, I have mentioned here the local host and 9092. When you are accessing within the container, we will use the broker 01 host name and 29092. So here auto offset reset is earliest, which is more like start read the data from the beginning. Okay. So here you can specify all other auto commit, consumer timeout, okay, and value deserializer. Okay, whatever the value comes, it's a JSON payload. So we are going to mention it as a JSON data format, and the consumer is going to subscribe on the topic. Okay, so once you run this Python program, you will say the same data being subscribed here. Okay, so both are basically the same thing. We are either you can use the CLI or you can use the Python API. Okay, so let me stop the publish here, and there are other commands which you can explore. Okay, so you can check the current status of the offsets. Okay, for example, which message, in case if your message stops, which offset it is. Okay, so next time when you consume the message, the offset will be maintained and the Kafka will consume it from where the data is left. Okay, or if you want to consume from the beginning, you can still do the same. Okay, so it's up to the user's requirements. Okay, so there are other similar useful commands which you can explore, and you can try it on your own. Okay. Thanks for watching, guys. Let's make technology easy peasy for everyone. In case if you have missed to subscribe to my channel, please do subscribe and support me. Okay, so I'll see you with more interesting contents on IoT, cloud, and open source softwares. Okay, thank you very much.